Hallo en welkom weer so by Farmspace. Okay, ons weet spuite is nie so eenvoudig soos wat dit lyk oor die algemeen nie, net goed nat spuit nie, met actually druppels regte grootte druppels kry, regte druk, al daai tipe van goede. Ons was onlangs by 'n boeredag saam met Syngenta gewees en Jack Pickering praat 'n bietjie oor hoe bepaal jy jou droplet size, jou druppelgrootte en dan ook jou druk en al daai goeders en hoe belangrik dit is. Ons weet almal jou chemikalie is hierdie deesdae baie duur, so jy wil die maksimum uit dit uitkry. Kyk hierso, beloof dit gaan vir die moeite werd wees.
Okay, so what are we going to talk about today? We're talking about factors that affect spray quality and deposition. So my whole purpose here is to basically help you guys spray hopefully better, is the idea. And what we're going to talk about is there are 5 main factors that affect spray quality and deposition, and that is your droplet size, your pressure that you're running your machine at, the speed that you're traveling at, boom height, and then weather. Weather's a complicated one, so we're going to leave that one for another day, and we're going to focus on nozzles and machines, which factors droplet size, pressure, speed, and boom height. So these are obviously well within your hands to control. You know, your nozzle selection, and obviously these two are very easy to control, and both of them have a big effect on how the products work. At the end of the day, you can have the best product in the world. If you don't put it in the right place and you put it correctly, doesn't matter how good the product is, it's still not going to work effectively. Okay, so I'm going to start with droplet sizing. This is a standard across the globe, so if you go into any nozzle booklet, it'll have the VDM of their nozzles. This means basically, so there's a color coding, and then there's obviously symbols for it, and then also obviously the extreme fine to ultra coarse. I'm not going to go through them all, but basically what that means is, it means that if a nozzle catalog says to you that the nozzle produces a medium-sized droplet at 2 bar, what that means is that 50% of the droplets that come out of that nozzle are going to be within this medium, which is 226 to 325 size, VDM range, microns. What we want to try avoid, guys, is small droplets. So small droplets are great for coverage, but the problem with small droplets, there's an F for fine for a reason. They tend to bugger off, they tend to disappear. They're very susceptible to drift, and they're also very susceptible to low evaporation. So you want to be basically higher than a fine droplet on average. So you want to start around medium to coarse to get away from these drift problems and also evaporation issues. Droplet size of 190 is double the weight of 150. A droplet size of 240 microns is 4 times the weight. Why is that important? Because you'll see here in this fine category, basically on the lower end, they're already in that 150 dangerous zone. And on the higher end, they're still less than this 240 micron, which means that even though you can operate a nozzle producing a fine droplet in a range that's not badly driftable, it's not really where you want to be. You don't want to go stand right next to the edge of the cliff if you can avoid it, basically, is what I'm trying to get at. You'll notice also that nozzles, this comes straight out of the T-Jet manual, and you'll notice that what's happening here is that flow rate is basically a blue nozzle. So these are all blue nozzles, different types of nozzles, and these are 2 different pressures that they ran these nozzles at, and this is the amount of driftable fines produced by those nozzles. So this is important to understand, because obviously you can really affect the droplet size by just selecting the correct nozzle. You can get a very coarse droplet, which is great for windy conditions, and then you can also go to some of these others when you need more coverage as well. So these things are very important to remember, and that obviously if you're running, ideally stay away from the XR, but if you're looking at like a TTJ, you can see straight away that at higher pressures you're going to have increased the amount of driftable fines, which also means that you're going to spray in good conditions. This is a nozzle that you're going to spray in good conditions. Whereas your TTR, which is an air induction turbo T-Jet air induction nozzle, you can spray in much windier conditions because you're producing a much bigger droplet. But then obviously for post-emergent crops and stuff, you also just got to watch out that droplet size is not too big. So expanding a bit on the droplet and what I was talking about now, the other thing that affects coverage is also the amount of water volume you spray. So this is done in a lab, so we're going from 112 liters per hectare to 38. You've got a 75 in the middle. What I'm trying to explain here is this is an extra course, so this isn't even the biggest droplet you can get, and then going to a fine. Now you'll notice at 38 liters with a fine droplet, you're still getting great coverage on this water sensitive paper. But if you drop that down to an extra course, now all of a sudden that coverage is not so great. But if you move across to this side, that coverage is improved drastically because we've increased the amount of water. Why is this important? It's important, like especially now this time of year, you've got relatively low humidities, you've got quite a lot of wind, and you still got to spray pre-emergence very soon. So you could select a nozzle that produces an extra coarse to sort of ultra coarse droplet, a big droplet, but then just increase your water volume and you'll still be able to operate. Whereas if you stick to a specific water like 100 liters, you're going to have to stop spraying as soon as the wind picks up. So these are sort of practical ways for you to get the maximum out of those machines. Any questions, guys? There are knives. There are knives for those who ask lacquer questions. So please ask. Any questions around this? All good. Okay, so we've spoken about droplets and what effect they have on your spray conditions. We're going to move on to pressure. So pressure, there are sort of three main things that pressure affects. It affects your spray angle, first of all. So obviously lower pressures drop the angle of the nozzle, and higher pressures increase the angle. Obviously, if you increase the amount of, if you increase the pressure, it's going to increase the flow rate of that nozzle. If you decrease, it's going to, which is obvious. And then the other thing that's maybe not so obvious is when you drop your pressures, you produce coarser droplets. If you increase your pressures, you produce finer droplets. So when you get that VDM of, if you say your nozzle's a fine nozzle and you're basically pushing that nozzle to its extreme, you're going to produce a lot more fine droplets, and you're going to produce a lot more at the bottom end of that fine range, so that basically extreme fine. Whereas if you take that same nozzle and drop the pressure, you're basically producing bigger droplets and there's less chance of drift. It's also important to understand that nozzles operate at specific pressures. So this is an example of what not to do. This is a soybean crop, and they did it for a demonstration, but they sprayed over the top of this with gramoxone. So ideally you don't want to see any green in this situation, but we're getting lacquer green stripes. What's happening is they operated an air induction nozzle at lower than 2 bar, 1.4 bar, and this is where you're getting these straps. Now what's funny about this situation is the rate controller said nothing was wrong. And this is important, I'm going to repeat that. The rate controller said that you were still producing 200 liters a hectare, but all it did is it dropped the amount of pressure to compensate. Too low. Too low. So when selecting a nozzle, be very careful of this. And the other thing to also remember is that there's a pressure drop from the cab to the nozzle. It's not necessarily exactly the same thing. And the reason for that is most machines measure pressure at the pump, which is just obviously, so between the pump, there's a lot of pipes between the pump and the tip of the nozzle. And if you drop that bar just by 0.2, that takes you from 2 bar to 1.8. If you had to put a specific air induction nozzle on there that doesn't operate at 1 bar, now all of a sudden that nozzle's not operating anymore. Your controller's going to say everything's fine, but the nozzle's not. Okay, so speed and pressure have a correlation, especially when you're talking about rate control systems, where obviously as you increase, to keep it at, if you've set your rate controller at 200 liters or 100, to keep it at there, obviously the pump has to increase. When it increases pumping, it obviously increases pressure. But unfortunately, pressure is a terrible way of changing flow rate at a nozzle. So if you've got a specific nozzle on there, and let's say you had a red nozzle and you wanted to go from 8 k's an hour to 16 k's an hour. To do that, you have to double the flow rate, right? Because you've now doubled the speed. To get that double flow rate, you've got to 4 times the pressure. So if you were starting at 2 bar and you then get to 16 k's an hour, that's going to be 8 bar that nozzle's sitting at. It's a little bit high, maybe, just a tad. What does that mean in practice? So If we go to 200 liters a hectare, what's going on here, guys, is that's the different sizes of nozzles. This is the pressures that they'll operate at. If I fix a 200 liter rate, these are the different kilometers per hour. So what I've done here is to simplify everything. I've ranged from 6 k's an hour to 12 k's an hour. And then this is the droplet spectrum that those nozzles are going to produce. And the important thing to take away from here, guys, is that a O3 nozzle, as an example, if you want to put an O3 nozzle on your machine and you want to run at 200 liters a hectare, as soon as you get to basically 7.2 k's an hour, that's going to be sitting at 6 bar with that nozzle. And you'll see that this particular nozzle, that's a TT nozzle, doesn't operate at that bar, doesn't operate anything above 5 bar. So now straight away you've got a problem. If you move to a red nozzle, it'll operate in that, but you can see you go from extreme coarse to medium. That's quite a big range. So now if you're spraying pre-emergent herbicides, you want to be there. And when you want to spray fungicides, you kind of want to be here. But now if you've only got one nozzle and you're going to vary your speed, now which one's right? You know what I mean? If you're spraying a pre-emergent, you put a red nozzle on and you start going 12 k's an hour, depending on the type of nozzle, obviously an air induction will change that. This is for this specific nozzle. What you can do is then size up, and you just got to remember not to go anything slower than 6 k's an hour, because that's going to be less than a bar. But the point of this demonstration is to show you that the choice of nozzle you choose has a big effect. Even if you've got a rate control, it has a big effect on your droplet size and the pressure that you're going to run your machine at. So these are all things we need to take into consideration.
So right, dit is Jack Pickering, Syngenta. Net so rondom jou druk en jou druppelgrootte. Kyk uit, daar's nog video's wat kom rondom dit. Ander handel meer oor jou spoed en jou boomhoogte. Op die einde van die dag seker maak jy die ding reg spuit. So kyk uit, moet hulle nie misloop nie. Dis hier van Farmspace af. Tot volgende keer. Groete.